This is pre-calc notes on section 1.3. Find the nth term of an arithmetic sequence. The objective students will be able to find the nth term of an arithmetic sequence. Okay, we're going to start out with a pretty easy problem. Find the nth term of an arithmetic sequence with the first term -3 and common difference 4, and sketch a graph of the sequence. Okay, we have the formula that I taught you in the previous section. This is the explicit form. And if no one tells you otherwise, that's what we're looking for. The explicit is a much more mathematically eloquent formula than recursive is. So we're looking for, since this is arithmetic, okay, we're going to use u sub n is equal to u sub 1 plus n minus 1 times the common difference. All right, they're giving you the two things we need to know. They are giving you the first term is -3, the common difference is 4. So all we have to do is just plug them in. U sub n is equal to -3 plus n minus 1 times 4. I'm going to put this in simplest form. I'm going to distribute the 4. Combine like terms. And now I want to point something out here. This can be thought of in the form y equals mx plus b for a linear equation. You already know from our discussion 2 videos ago that arithmetic sequences have linear graphs. And if it's arithmetic, it has a linear graph. And so the slope is 4 and the y-intercept is -7. So it's asking us to sketch a graph. It's linear. The first term is, actually the 0th term is -7, but this starts at the first term, which is -3. So when x equals 1, or when n equals 1, y equals -3. And then the slope is 4. The common difference is 4. It has a constant rate of up 4 to the right 1. So I'm going to go up 1, 2, 3, 4 to the right 1 and put another dot. I'm going to go up 1, 2, 3, 4 and to the right 1 and put another dot. Okay, that should be linear. All right, what is the 38th term of an arithmetic sequence whose first 3 terms are 15, 10, and 5? So now, if you had enough time and patience and accuracy, you could list 38 terms of this sequence. But it might be faster to come up with an explicit formula and then plug in n equals 38. And so that's what I'm going to do. U sub 1 is 15, okay? My common difference is -5. This is decreasing by 5. So U sub n is equal to the first term plus n minus 1 times the common difference. I'm looking for the 38th term. I'm looking for U sub 38. So I'm going to plug 38 in for n. So I've got 37 times -5. I'm going to get a calculator as quickly as I can. I had to walk all all the way across the room for a calculator. So 37 times -5 is -185. -185 and +15 is -170. All right. Here we are given the 5th term and the 11th term. Let's take a look at this. All right, so the 5th term is 22. And the 11th term is 64. All right. I'm not given any consecutive terms, so I can't just subtract to find the common difference. But because this is arithmetic, that means that it is linear and that the common difference is equal to the slope. So I'm going to use the slope formula to find the common difference. So I'm going to use 2 ordered pairs. So the 5th term is 22. If I write that as an ordered pair, and the 11th term is 64. I'm going to write that as an ordered pair. The slope formula, y2 subtract y1 over x2 subtract x1. And I'm just going to plug those 2 points in. So I have 64 subtract 22 over 11 subtract 5, which is equal to 42 over 6, which is equal to +7. So the slope of the line is 7, which means the common difference of the arithmetic sequence is 7. All right, I could just count backwards from 22 to find my use of 1, but for this I want to get you used to using formulas, so instead I'm going to plug this into explicit form of an arithmetic sequence. So that's use of n equals use of 1 plus n minus 1 times the common difference. And right now I'm looking for my first term. All right, I'm looking for my use of 1, so I want to plug in everything else. And so I'm going to need a use of n, and I'm going to need a term number. I'm going to use the 5th term to find my use of 1. There we go. Use of n is equal to, oh, hold on, backwards. I'm using the 5th term, which is 22, is equal to use of 1 plus n is 5, so 5 subtract 1 is 4, and the common difference is 7. So 22 is equal to use of 1 plus 28, which is -6, or so use of 1 is -6. All right, now that I know my use of 1 and my common difference, they're asking me to write a recursive and an explicit formula. So I'm going to do that now. Recursive. I have to state the first term, which is -6. A recursive formula for each term that follows that. So use of n is equal to the previous term plus the common difference, which is 7, for all n greater than or equal to 2. And now the explicit. So use of n is equal to the first term plus n minus 1 times the common difference, which is 7.